Now we're serving not only that enterprise developer who understands IoT, but we're serving the person who just wanted an app to see what was going on with their stuff.
Welcome to the second video of the 1ClearThing series. Today I will speak with Aaron Allsbrook, the CTO of ClearBlade. Aaron has extensive technical background and hands-on experience in designing and building distributed systems. During today's conversation, we'll analyze one of the core dilemmas in IT, which is whether to build or buy an IoT solution, and also why open source is not always the best way for IoT deployments. Hello Aaron, it's a pleasure to meet you.
Lukasz, it's very nice to see you and meet you again today. Thank you for having me on.
ClearBlade was not your first endeavor. Could you summarize your track record for the audience?
Yeah, I began life, I guess, coming out of school as more of a computer engineer. So much more on the hardware side, as was my training in school in NC State University. I then jumped right in and did software at IBM. So I was kind of in the IBM software world. Most of my experience was in the development tool set for applications. So thinking about if you were to try to build an enterprise application in the early 2000s, that was the tool sets that I was working on, and then kind of helping it run once it was deployed. Did that for a number of years, and then I moved into actually helping customers use those tools and really learned that just because you built it this way in the lab, it's not how the customer or the user is going to use it, and you got to be ready to be flexible. A really fascinating set of experiences of both seeing the real software development lifecycle process and how a big company would do that, and then seeing how it's adopted and actually used in real life and trying to figure out how you reconcile new requirements coming back and forth. Kind of came into ClearBlade after having done that more consulting, management consulting, application consulting role. So have lived on both sides of the person trying to build the thing and also the person building the product that thing sits on top of.
I think that gives you that end-to-end vision. As you said, you lived on two sides of the same challenge, so to speak, but every side got different perspective, different KPIs, and tries to reach essentially different goals, even though they try to build the same.
Yeah, no, it's amazing. You feel like you learn so much building a product, and then you go out into the world where it's being used and you realize, well, there's this whole category of the product being used this way. And then over here, they want to scale it as small as possible and be as efficient as possible. And these folks are feature heavy. And it was a lot of learning and then massive learning on steroids after that once you're out in the field, for sure.
During the previous episode, Eric described the founding story of ClearBlade from the business perspective. Could you elaborate on the early days of ClearBlade from technical standpoint?
Well, I've heard a little bit about that episode, although I don't think it's published yet, so I haven't seen it live, but I can imagine what he might have talked about. Eric is one with a great vision, and he came up with the vision for we're seeing a lot of exciting things happening in the startup world and how that behavior and development process is working for mobile and connected devices. And we're seeing a different behavior in our enterprise customer set. We've always been more enterprise focused, big customers trying to build applications that last, 10, 20, 15 years. And they were just so different from each other. And he really comes with this vision of let's build this product. Let's build this product that gives enterprises the new way to build, right? The cloud hyperscalers hadn't really launched all these features yet. So, the idea of a Lambda function didn't exist. And he said, let's build this and let's make it for enterprises. And I really thought it was a terrible idea, to be honest with you. I couldn't imagine how, I was like we're going to have to support things 24/7. We're going to have all these bugs. If I go and I look in the ecosystem, there's 27 open source projects doing something kind of like it. And we're already behind, Red Hat and IBM and all these other companies are already doing it. And we probably had a month of going back and forth. How are we really going to do this? How are we going to differentiate? How are we going to catch and get ahead of the market? How are we going to, what are we going to raise our fund story around such that we can do this activity? So it was certainly a big vision, and it's a vision I would say we've achieved. But to imagine from a kind of a small team how we were going to get here, it's a really hard way to look at the world. Especially when you know that there's so much going on, so many brilliant people doing different things. But we dove in. We did a lot of experimentation to start with, tried lots of different languages, really debated features. It was very important to me that we be unique. So we not just be a copy of something that was out there, but really have a unique architecture, a unique way to solve the problem that we believed was better. And Eric turned us loose. He basically gave us the freedom to start building, and we obviously had some timelines and deadlines and some pilots to achieve along the way, but always really respect how he trusted the team, trusted the engineering team, trusted me, trusted the other engineers to really go at it. It was a world full of Node.js, and we didn't use Node, right? It was a world full of everybody's got to be a document database, and we said maybe relational is the right structure for, it was totally letting us make the decisions in the technical point, not just, where the technical hype had gone at the time.
Eric was the one that created the vision of building IoT platform, and you was responsible for making it happen, essentially. And I've been in a similar position several times, and I know firsthand how challenging it is to convert a vision into tangible solution. Could you give us a bit more insights of how you approach that task? Because you just casually described it, but I know that this is not that easy and straightforward.
Yeah, so he painted this vision for this product that could, basically allow for mobile devices, embedded devices, things to connect to a common system, the ability to do work against the data that's coming in, the ability then to take action in enterprise systems downstream. That's the vision, right? And if you think about what IoT platforms are, that's, left to right diagram of stuff comes in, things happen, stuff goes back the other way. But, in the technical world, from my background, I was in the Java space back then, and it was, you had JMS, Java message servers, you had message brokers from major vendors, you were installing J2EE application servers, you were picking large databases. And I really looked at that problem and said, okay, if we're going to solve this the way that Eric changes the vision, is we've got to tighten this ecosystem. We've got to pull it together. That's how we're going to be able to run far more efficiently than what's out there, right? That's what we're going to be different. We're going to understand that these requirements are always the same for middleware, put them tightly coupled together, and then make them very easy to deploy anywhere. Easy to deployment probably was a really high requirement early on. And so that really changed a lot of decisions, quite frankly. It's really behooved us because we are on-prem, on any cloud, running on gateways. So, we have a lot of flexibility where we can take our stack because of it. But I would say that was unique at the time, was trying to solve that kind of being able to be ubiquitous wherever we ran. Once you saw the problem, then it was break it down. I just described 3 pieces of middleware turning into one, and you say, okay, we got to either find these pieces and put these pieces together and make them our own, or we have to start from scratch. And so that was really the journey of we wrote our first pilots in 4 different languages, right? And performance tested them, scale tested them, did all these kinds of things to them. It's actually amazing to think about the patience people had with us to get this out the door, right? To really kind of understand what problem are we solving.
Well, if you're building something as important as IoT platform, which is essentially the most important system for your customers in the future, then it is quite obvious that you need to make it right. And designing something is always fun, but the implementation always shows some challenges. The approach that you took by choosing different languages. So this is essentially the lowest possible level, right? You've got number of languages that you can use, and of course you've got the higher level of abstractions. So if you developed that prototype in 4 different languages just to benchmark each other, I think that's huge.
A lot of teams go down to very small when they're starting and incubating. So it was a small set of us. We all had different skill sets, and we all kind of wanted to know, all right, we're all going to have to kind of converge, right? So just because this person likes Python, just because I'm a Java person, just because we've got somebody else who wants to try the latest and greatest or loves Erlang, right? All these things were pilots we had to kind of sit there and say, how are we going to work as a team? What gives us we're building a product, right? And so that really was that early journey. I'll say the other interesting thing is there was a real tendency at that time, not only to, just kind of pick popular technologies, but a tendency to kind of name things in fun ways. Right, it's a thingy, it's a doohickey, right? And we had all this kind of teasy software, and we kind of just said, we're going to be official, right? A microservice is a microservice. That's what we call it. A database is a table, or it's a collection, right? And we worked very hard to kind of keep true to what our industry understood, even though we were changing the paradigm of how these pieces came together and how you built an application. But But yeah, it was a lot of patience and a lot of trying different things. Obviously, you look at open source, which I know is the topic of this. We looked really, really heavily at open source as well.
So choosing to develop things from scratch, this is the most extreme option, right? And which aspects of available open source solutions you analyzed before deciding for custom development?
Yeah, so there was some inspiration. Maybe the good news for us was there wasn't an open source project that looked exactly like, or at least we couldn't find it looked like what we wanted to build. We believe with IoT there would be extreme performance constraints, meaning the message had to move and be delivered very, very fast. So there's just some languages that have hiccups in the memory and how they kind of do it, right? And so we kind of could even remove some open source projects because we're like, this isn't going to actually process where we need to go at the scale for millions and millions of devices. We had the true vision. We were going to scale up. We were going to go cloud scale. And so that helped make some decisions. Kafka had been released and it had some interesting ideas. We tried to deploy Kafka and I'm not sure if you remember from that period of time, but it was extremely complex to run. There are reasons why there are companies today that's only job is just to run that piece of software, right? Back then it required like Zookeeper and other things to make all these pieces and parts go. We knew that wasn't our, deployment flexibility was our key. And so things like that were removed pretty quickly. There were some low-level things. We don't want to rebuild low-level. There were some MQTT brokers that existed. We knew we would want to extend it. So whatever language that broker was in, we would be building on. The MQTT 3.1 spec was out, but it wasn't necessarily in a way that people were clear on how they'd scale beyond one broker. How do they bridge behind the scenes? The security model wasn't very clear. How do you make sure this device can only see its topic? There were some things about it that kind of just said, all right, we're not going to be able just to go grab a Mosquito and be done. And so, we looked at that. We did love those things. We integrated heavily with them, right? The Mosquito clients, being a client to their brokers, all of that was important to us. But we just knew for us to deploy that architecture and the way we envisioned, we ultimately didn't see the perfect thing out there.
The ease of deployment that you mentioned, actually this is a huge factor, not only when you started, but even nowadays. There are a number of IoT platforms and tools that are not that easy to deploy and operate, to be honest. So once you make them run, they will run, but you never ever will touch them again because you might break something. I think that the decision that whatever you're building needs to be easily deployable, that's a huge factor, even nowadays.
Yeah, and it's actually wild because, we obviously built our product behind the scenes and we wanted these pieces of middleware and we were containerized very early. We were containerized back when people were telling me containers are not for production. You can't do this, right? And so we leaned into that technology. We happened to pick Go. Docker was written on Go, so it was very friendly for our environment to understand what was going on. But ultimately, we built a version of our product which everything was decoupled in different containers and you would scale up different containers. And there was a moment where I was like, we've rebuilt Kafka. This is chaos, right? I got all these, and I look at some architectures today where people have kind of piecemealed things together. And I'm like, there's 72 containers that are part of the production app. That is so hard to manage. And so, really what we've done is just keep it as simple as we can. We don't build a database from scratch. There are great databases out there. We don't build caching layers from scratch. There's open source caching layers that we leverage because those are highly optimized. It's a very well understood function. Looking at the IoT platform space, I would say still we probably don't see the open source platform that is the end all be all of what people probably need for this challenge.
One interesting decision that you made is that your solution needs to run on a single core. What made you focus on a single core devices?
Well, I wish I could say I knew the edge market was coming, right? And I knew that we'd want everything in the field. We did have a strong requirement to make sure we could run on premise on a Linux box, industrial PC. So we knew that existed in the market and we wanted to meet that need. It was hard because the whole world was leaning into cloud at the time. And so we were pretty unique trying to still make sure we honored that. But there was also a lot in terms of the cost model. The way the clouds were priced back then, you could use a lot of very small micro machines cheaper than you could use one large machine. So the idea that you built a cloud scale architecture with micro instances could actually be a pretty significant cost savings and add to your overall software margins as a software provider, or reduce the cost for your customers to run. When we bring in a dependency, what's it going to cost us? What's it going to add to the overall deployment? What's it going to increase performance-wise? So, it's not exactly hand in hand that you can run small and perform fast, but there's lots of things, lots of decisions you make that kind of will help those. And so that's what we've leaned into. We've always said we need it to be able to be incredibly performant on legacy processors. We've also managed to cross compile with the edge space. So, we're not having to have the latest x86 chip to make things work. We can use older stuff, and that's incredibly important for the industrial markets we serve, because they don't want to buy the most recent computer. They want to use the one they bought 5 years ago, 10 years ago. And that gives us some flexibility in a market where a lot of folks are always pushing to increase that overall operational cost or capital cost.
That is correct. In the industrial IoT, in factories, they are not running latest and greatest hardware and software as well, right? So you need to play nicely with all of those legacy systems, otherwise no one will purchase your solution. But you mentioned something interesting, speaking about the cloud, and you decided to be cloud agnostic, which from one hand gives you all of those benefits, but from the other, to be cloud agnostic, you need to use very basic cloud services, because if you try to use higher level services, those are not easily mapped between various cloud vendors. So how difficult it was to build a solution that runs in the cloud, leverages the scalability of the cloud, but at the same time is really cloud agnostic?
Yeah, so again, you talk about were you behind or ahead of the industry. Cloud functions didn't exist from the clouds when we started. We had a vision to implement cloud functions. MQTT brokers didn't exist. They still don't exist in pure manner as hyperscaler functions today in the clouds. We knew we wanted a fully compliant MQTT broker with all the QoSs. So on one hand, some of the core things that made us compelling and powerful of a product, you still probably couldn't do today on one hyperscaler, much less move between them with the different services. It did take more time, certainly, to build a product. We are a software product company. Software product means our job is to make the best of breed IoT runtime in the market, which means we are constantly innovating. So while some folks may want to build a solution and never update it, our goal is to constantly be providing new features, new capabilities, new protocols, new performances, new types of encryption, all of that making it available, new types of AI, making it available into the fundamental AI platform or IoT platform. So, we're kind of constantly pushing that angle of our product couldn't be replaced by features that are out there, right? The compute's great. Compute is like the electricity in the wall. We'll use that. There are fantastic services that we do integrate with. Kubernetes deployments across the clouds, frustratingly, they're a little different, right? EKS is different than AKS, which is different than GKS, which is different than OpenShift. We have to basically write deployments for all of those, right? The Helm charts and the differences and Terraforms there. Logging tools, each cloud has great logging tools. Most people who are using a cloud want to use the native logging tools. We've had to abstract how we pump our logs out. All clouds kind of created some sort of data flow service for kind of downstream how data might go. They're all very different, right? Kinesis looks different than PubSub. And so ultimately we have to kind of create similar connectors, but yet different connectors. But that's how we played it, right? We basically try to stay true to what we believe is core to IoT, receiving the data, processing it, updating alerts wherever you need to go, making sure it's all secure through that, but then play extremely nice with the rest of the ecosystem around the way. And we have learned that there's pieces like, dependencies where we have a database. We can swap our database for the cloud offering, which is great for folks who want that. So, we will absolutely play nice with those other services, but our service, the core of what we are, we can keep, we have, and it is unique across all of the hyperscalers.
So I would say you are not really cloud agnostic. You just abstracted away all of those complexities, created connectors to leverage specific functionalities of specific cloud providers, but from the, let's say, customer perspective and even the administration perspective, you are cloud agnostic because you expose the same APIs to your end users, right?
Yeah, I mean, that's a good point, right? I mean, if you're using us on AWS or Google, you're using EKS and you're using Google logging and monitoring, right, for how you manage it. So that's a good point. And so we're totally agnostic and where we'll deploy, but ultimately we are tying into those systems to make a good experience for our customers.
Exactly. So how has ClearBlade's technology evolved over the years? Because you mentioned experimentation, but at some point of time, you had to ship your solution to the production. And probably after a few years or maybe even a few months in the production, you realized that you need to change something because something happened that was outside of your control, or maybe some customer used your software not the way that you envisioned.
Yeah, I mean, one great example is performance. You think you're fast when you build your first version, right? You made fast decisions for how you'd move data. And then someone comes in and, you tested 100 a second and they test 10,000 a second. And you suddenly see a whole new set of profiles come through, right? Early on, we were microservices. A message would come in and a microservice would fire. And there was basically a warm-up time to that process, right? For that runtime to get hot, right? If you think about it, your JavaScript or whatever would have to run. And very early on, we said, wait a minute, we need stream services. We need things that are always hot, always subscribed, ready to process. Again, you don't get quite the same security model because now many things can enter the same way, but essentially it's kind of that back-end processing. And we added stream services, which probably gave us 1,000 times performance speed up, right? It blew our minds with how much faster we suddenly made our product with not envisioning that out of the gate. And it changed very little in terms of how we ran it. It just was a microservice that stayed hot and stayed subscribed. We've gone a lot over the architecture itself, right? We've tried, our microservice engine has changed over the years to be more and more efficient. Things like V8, and that's a JavaScript engine that runs inside of our Chrome browsers. That is a heavier memory footprint than others that are out there. Putting that memory footprint in our own lifecycle process, right? So can you put the C code inside of your Go code so they share resident memory? Yes, you can. That was a dramatic performance increase. So I would say we have really leaned into that. I mean, down to converting memory types and speeding that up at levels that I would never have imagined. Then I think the deployment model, again, we did kind of follow what are today, might even be today best practices of all these isolated groups of different containers that scale and cluster individually and different node pods of nodes. And we kind of said, this is too complex at scale. We need to have one kind of container that scales out and then can handle a lot of the idiosyncrasies of those different pieces. That single binary was a dramatic change for us that we really considered a turn in our product, and something that we're really proud of and really has behooved us and differentiated us in the market. We've continued to add new features. We added an AI engine. I would never have thought we would bring AI into the real time. We call it dynamic inferencing when you're kind of doing the AI inferencing on the hot data as it comes in. That was probably a big kind of light bulb moment for us as well when it looked like all the world was doing AI and we had nothing to do with it. Suddenly we realized, wait a minute, we're where everybody wants to do AI. We're unlocking the data. And so that was a big exciting point for our product. But in general, we serve the enterprise middleware developer very well. Someone who understands IoT can very quickly grab all that value prop. But I would also say we launched another product called Intelligent Assets. We had custom projects with a large mining company, custom projects with a large railroad, custom projects with an aircraft manufacturer, custom project with a water utility. And there was a moment where I'm like, guys, we have built the same application 4 times. It's the same thing. We went in and we created some data structures for the devices that turned them into assets, and we put some rules around them, and we put them all on a map. Why are we building this application over and over and over? Digital twins, so to speak, that term didn't exist all that much back then, but it's this idea that you can see your thing. And that was a big wake-up call. Now we're serving not only that enterprise developer who understands IoT, but we're serving the person who just wanted an app to see what was going on with their stuff. And so, there's been tons of growth, right? And good grief, our backlog is enormous. So there's so much more to do. Anyone who thinks IoT is done, there's a lot coming still down the pipe.
intelligent assets and digital twins. We will dive deep into those topics during our next conversation. For now, let's focus on building the foundation. And you said that you were mixing a number of technologies, number of programming languages to squeeze as much performance as possible. And I believe that increased the complexity of the whole solution. And you briefly mentioned about it that you tried to reduce the number of abstractions and make things a bit easier to manage. What is your secret rule regarding management of the complexity? Because software, where you start, it is very fun to add new features, but after a few years, no one wants to touch that anymore. So how you handle that?
Yeah, so, we really do have a brilliant team behind it, right? And so we have some brilliant engineers who really love this back-end problem. And it is a back-end problem. We are putting multiple pieces of back-end middleware together and making them run as tightly as possible. What we do, and maybe it's a little different, a lot of the cloud hyperscalers just create new services, and some of them just deprecate them when they're not used, and others are just creating more along the way. We've really tried to say, unless you can't build the IoT solution in us, we're not necessarily going to add more pillars to what's going on. We receive the data, we process the data, we help you store it, we help you tell somebody what's happened. But we really live in that life cycle. And so for us, we're not having to do a tremendous number of major new features. We don't solve the network problem, so to speak, right? We expect an IP address. We expect to have an TCP network connection. We are not trying to change the security model beyond encryption, authentication, authority, right? So we'll give you role-based authority, but we're not going in and creating and innovating around potentially new models there. We're going to use the foundational principles that all enterprises are for. We're not reinventing the software development lifecycle. We have a CLI. You can push from dev QA to prod. You can do local development. We have a web IDE. These are all things and way enterprises work with whatever tool set they've picked. So we've managed to kind of make sure, and this might go back to the background that Eric and I had, to make sure we live within the standard SDLC, within the standard kind of environment that DevOps people are working, within the standard innovation cycles that are going on with network security and stuff, and kind of stay in that spot. And then sometimes it's meant that analysts didn't know how to categorize us because we had kind of created our own category, and we refused, right? A lot of people in the edge space have gone and made container managers. You can do that with us, but that's not what we're about. We're focused on sticking to how do we do the IoT platform function, which is securely connected device, process the data, and then either store it, persist it, or act downstream into an enterprise system. And that really has been a kind of golden path for us and kept us from chasing too much. The blockchain excitement came and went during this, right? Tremendous pressure, do something with a blockchain. And we just said, I guess we could write to a ledger, but it's not our job to do blockchain in this story. And our focus there has really behooved us along the journey.
Your experience in the enterprise IT really pays off because you understand how enterprise works in a way that the processes, the IT departments, release of new versions and whatnot, right? And what you just described fits perfectly into those templates. So it is very easy for those enterprises to adopt your solution because it essentially works the way that they work internally, or at least they would like to work internally. Right?
That's right. It's the North Star for all of us, to be agile, but yet controlled processes with release cycles.
Exactly. You described the backend. How do you manage the edge devices? Because you provide that edge part that, as you said, it can run on a single core. So how you manage that edge device and securely connect it to your backend?
Yeah, I mean, actually, that's probably you asked about major things that happened over our journey. That was probably a major one to kind of realize where we could help. We definitely knew people wanted IoT platforms in the cloud, and we knew people wanted IoT platforms in the factory on the truck, right? They wanted all the things to talk to each other. So we had always been building our product to handle both. But there really was a moment where we realized we need these things to work together. We need all the trucks to go back and communicate with what's in the cloud or on the IT servers. And so we basically said, all right, our stack will run on both. The only difference is we have this much space to work with on the device in the field, and we have infinite space in the cloud. So how do we basically take these architectures and deploy both of them? What do we change, right? Well, we changed the database model for the edge to be a lighter weight database persistence. And we basically made sure that the process didn't go beyond what was available to it, right? So we told the platform, just stop, protect yourself. And then meanwhile, the cloud could grow as big as it wanted. We could put more compute in and it would just keep taking more devices. So really the profile became easy. And then it was, well, how do I very quickly, write my logic, define my device, create the data structures necessary, put my rule information, how do I take it from the cloud or my IT servers and deploy it to the edge? And that was where this special kind of sync idea happened. And so now what that means is it almost looks like they're bridged together. That would be the MQTT term, where if something happens at the edge, you can say the policy for this is it will sync this device record up. Maybe it updates the device to the cloud every 5 minutes. Maybe it's in real time. Maybe it never updates. Maybe it's just log files that live on the edge. But you can define the log structure and everything from the cloud, push down the deployment, and then let it work. That's been a fascinating part of our product because I think that's where the industry will go, right? We've lived in a world where, we were all mainframe centralized, then we all got PCs, then we all went to the internet, then we all got mobile phones. The reality is some is centralized and some is distributed, and we then have to be able to move that application back and forth. And that's what we're doing with our kind of edge to cloud model.
In a way, cloud is just a huge centralized compute, right? It is not, well, it is distributed, but from architectural standpoint, it is centralized compute. So it is the classical client-server approach, right?
Yeah, so even if I were to deploy containers across many different regions, it is still the one application things are rolling into, right, and becomes a source of truth. And there's meshes and stuff are great, but you do need data to roll up to have a central source of truth for most enterprises, right? That's where they want the data. They want to own that truth. And so it maps well to the architecture and enterprise patterns that are out there.
I've got a tricky question. How do you handle remote software upgrades? Because recently we witnessed huge issue caused by remote upgrade of Windows platform. I know that you personally was impacted and spent number of hours at the airport. So how do you ensure that you won't break your customers' devices because you shipped the upgrade that doesn't really work as expected?
Yes, I spent a lot of time in the airport, and it was it was a long weekend. I'm very grateful to be home and grateful that we're all back to normal there. So you put in place policies. Number one, bugs happen, right? So you have to understand that. So obviously there's a whole QA, and I've read a lot of articles about the quality assurance and stuff along there. But the reality is you also have to plan for recovery from if that gets all the way to that point. So we do things like our edge process when it starts. If it can't recover, it immediately rolls back to what it was, right? That was just kind of a fundamental. If we're going to automatically update our device, we have to be able to go back to what existed before. We have the advantage of typically running potentially in a container or potentially just running in the application space on the device we're on. So it would be a challenge for us to completely brick that device. We certainly could try and do it, but we're not reaching quite the same level of this recent event to cause that. But we do try to make sure, or we do build into the process and our test lifecycle that if it starts and if it begins and fails, it will immediately roll back to the previous version. And that is, step one in protecting against that. Quality lifecycle, understanding that ClearBlade has a device type that matches all of our customers. That's key. Supporting our customers to run their own kind of pilot upgrades is also key. I look at, being able to say, all right, my application's up. Maybe I updated my cloud side. There's a new edge version available. But instead of updating all 8 million at once, maybe we update 10. Maybe we let each customer update 1. So we kind of provided the ability to do some manual updates and let people kind of run tests into their production environment. It's sort of like an A/B test of our edge process. Each customer kind of defines their own. Some customers own their own deployment process and then kind of take that job over. But that's where we've really tried to play, ability to instantly roll back if things aren't going well, if anything's detected, or the ability to basically run pilots of the update into the production ecosystem.
You mentioned that your solution runs in the application layer, not on the OS layer, but still customers depend on you, right? So even if you won't crash the OS layer itself and your application just hangs, that is as bad as it can be. And I absolutely love the approach that you've got the logic that after the upgrade verifies if it is alive and if it is in a state that it can operate. If not, it will flip back to the previous one. Because always there is a chance that there are some issues, maybe some awkward hardware configuration or maybe network configuration. So having that automated rollback capabilities, I think that's crucial.
Yeah, I mean, and again, we talked about open source a bit, right? We've got some open source dependencies, whether it's just internal libraries or others. And you look at things like TLS termination, and when you're doing that, a single library update may change how, a particular cipher is used that you didn't even know existed. The ecosystem is so big, right? And so this piece of hardware with this cipher on this version, you just didn't recreate that in the lab. And we run on any hardware, right? So that's a great advantage, but that makes a lot of permutations of what could happen. So kind of building with the idea that failure will happen, and how do you recover from that? How do you make that easier for, we do honor helping our customers update to the latest software. That's part of what we do. IoT has got to be updated. So any software vendor that says, here it is and you're done, you're not going to be able to survive that way. So, for us, it behooves us to solve that problem because it's very painful for our customers and ourselves if it doesn't work well.
I've got one last technical question for you. What was the worst technical decision you made?
The worst technical decision I made? I'll come up with two. One is completely gone now, and another one that I'm still trying to figure out. The first one was we were early on trying to figure out how to do microservices. So no Lambda functions, no cloud functions in the marketplace. There was one other company that had kind of done something similar. We thought it was compelling. JavaScript is what we were doing, and we were trying very hard to create the engines, right? The ability to create a runtime, like a Node.js runtime for your customer's code to run in. We made some early decisions to kind of use a separate standalone server that could spool up lots and lots of Node.js runtimes, and it became incredibly difficult to scale and manage. It also had all kinds of challenges. Again, it was kind of an open source project, so we couldn't quite control the security between the VMs. We couldn't quite control the ability not to write something that could talk internally on the network in places it wasn't allowed to do. And so very early on, we got just a crash course in cloud complexity on how to protect people writing cloud functions, right? And I'm sure, just like we learned, I'm sure the clouds learned about how in the world do you do this in a way that's secure. Doing it with a pure, everybody gets their own container doesn't scale well, at least not from our perspective. And so having to do it in the hot runtimes, there was a big lesson there. So there was a technology choice based on Node.js at the time where we really kind of backed out and ran away from and said, boy, this is a feature we want, but we're starting fresh. I'll be more controversial now. We run on Kubernetes. It runs well in Kubernetes. We're big proponents of containers, but the cost of running with Kubernetes has gone up significantly over bare metal containers. There's constant space wasted. There is you're not able to optimize your architecture, change out the compute running as easy. Now there's some things it does well, but I constantly am looking at, our software margins have dropped, it cost our customers more to run. And so that is an area where we have to absolutely invest because, it doesn't matter how fast your software is. If you're only using 10% of that computer and that's how Kubernetes used it, then you've created a problem for yourself. So I'm not saying that's the worst decision I've made, but we are certainly not where, and I'm not sure who is in this space, is where they want to be with Kubernetes, so to speak.
I absolutely agree with you on the Kubernetes that it is great though it adds the overhead. And as you said, running containers on the bare metal, that would give you basically better scalability and better price for the hardware, right? Because you won't lose that much of the hardware resources just because you got the overhead of the Kubernetes. But on the flip side, that requires you to figure out a very smart way to handle those containers. So essentially, as you said with Kafka, you need to implement Kubernetes from scratch and do it the right way.
Yeah, and I don't want to rebuild Kubernetes. That wouldn't be in our swim lane, right? So we have to learn to use that tool better, or find a different tool. I don't think we're going to find a different tool. It's key for how we deploy so well. But definitely it is a thing where you look at, I'm willing to pay a 10% overhead, but am I willing to pay a 35% overhead, right? Those are real questions that come down to costs that impact us and our customers.
Yeah, and this is the customer-facing and customer-focused approach I really appreciate about you and the ClearBlade as a company. So let's switch to the customers. Why should customers use ClearBlade instead of building their own platforms from scratch? Because you've done it, right? You created the platform from scratch, so maybe your customers would be better off just building it from scratch. What are the benefits of leveraging ClearBlade instead of trying to design and develop in-house?
Well, I'm a technologist and I like to build, and clearly I chose to build from scratch. So anything I say too much, I will be disingenuous. I do believe that great software can be built from scratch, and it can be maintained and supported, and it can solve fantastic problems. I'm thrilled with what ClearBlade's able to solve today. I would say in the IoT space, we're not done innovating. So if you're in a situation where you think you know exactly what your requirements are, you know the requirements are not going to change, you know that the workload is not going to scale up, if you have a very clear understanding of what the final state will be, you probably can get away with a small project with developers doing open source. The reality is all of my customers continue to improve their solutions. They're constantly asking about new devices, new protocols, new speeds, new integrations. They're constantly doubling the number of devices for a couple weeks and then turning it down, right? They're changing their own volumes. They'll double the payload size and then realize their cell phone bill, right? I mean, it is because IoT involves so much operational people doing their own thing, and then the IT people involved, it is not done. I think anyone who leaned too far into open source and then got stuck in a situation where they just can't scale it without starting over, even with open source, again, starting over, or they just can't keep adding features and the investment it takes to add these features to bring it on, you've hamstrung your business. That's the challenge I see, right? I mean, I love open source. We use pieces. I'll be honest with you, sometimes the license changes, right? That's a big problem with open source for me these days, is the supply chain and the license associated with it. Got to make sure you're always honoring those. I guess not a big problem for me, but something you watch a lot. So, to me, I think there's a case for open source. Open source is amazing at basically providing a like-for-like functionality for a well-understood piece of software in the market, right? You can find a great open source database because databases are well understood. Brokers, you can find a good broker because brokers are understood in the market. But trying to innovate around those, get around the actual technologies, do more, adopt the new technologies in a way that makes sense for your business is a constant amount of maintenance and work. So, you probably, if you think you might have a 3-month, 10-person project to get it built, you probably have a 5-person project keeping it running and innovating along the way. So I think the expectations in your project for most people are something that you would rather not, that it's way more cost effective to work with a partner like ClearBlade or others that can have that application, take away that risk, do the innovation for you, bring new ideas to you. I mean, I bring new types of security models because other customers have done it. They get it for free. The fact that we can drop an AI engine in and here's how you build the AI model and here's how you do the inferencing, we give you that for free with the upgrade. That stuff is it's just part of what's going to happen and continue to happen for at least for a foreseeable future in the years ahead. And unless you're willing to pay that price yourself, a partner is in my mind a way better way to go, especially if your business isn't being software development. If your business is other things, then stick to your things that you're good at, and I'll stick to mine, kind of thing.
That is correct. Most companies are not IT companies to that extent. Like everyone have got IT department, but probably not skilled enough to build distributed IoT system properly. And when you said about the fixed requirements, fixed scope, I was about to basically scream that it never happens. It never happened to me, that even though customer was swearing that, yeah, this is all we need and we will never ever change anything, that never happened. So the assumption, as you said, that you will build something to meet this specific load, those specific use cases, that number of devices. Of course, you can write that from scratch. But then if the business owner decides that he really likes the idea and now you need to add 10x more devices, everything falls apart.
And the scarier thing is what you might have built, you built as pilot and you told them it was pilot. It's a proof of concept. And that thing is in production. If it works, it becomes production instantly. And now you have a situation where you haven't had time to figure out security the way you want. You haven't had time to understand how you're going to scale it. And so then it really creates a stressful moment for you because new requirements are coming in. You weren't expecting to be production level workloads, and here you are, right? And so that's, those are things to consider. Again, I love open source projects. We support several, and we believe in it. But ultimately, it's something that you have to support as well on your other side. So.
That is correct. And actually, I had to help a few customers that had exactly the issue as you described. So they were tasked with POC, but that POC went too well, so they were forced to push that into production. And then the security, the maintenance, all of that things that you need to have when you've got mature product. There is no time and space if you've got limited budget and you are tasked with just simple POC, right? So that creates very, very nasty scenarios. And the thing that you also mentioned that is very important is that I believe your customers right now can benefit from the scale, because for you to implement some very custom functionality for one customer and then offer it for free to the others, that basically means that everyone wins, right? Because you've got rich portfolio of your functionalities, and some customers may receive functionalities that they were never thought they need, but once they see it, they will understand how valuable it is for their use case.
Yeah, absolutely. And obviously it's easier to adopt it when you can see the value immediately. A performance impact over here that helps everybody, it makes it more efficient to run for our customers. So it is, it's building. And again, obviously open source has communities and they continue to improve. They're going to improve on their own kind of investments. When you're working with a partner like ClearBlade, we're directly meeting the needs of the customers as they come up with the request.
Let's switch for a second into the closed source. So some time ago, Google decided to shut down its IoT offering, and you helped a number of customers to migrate their workloads from Google IoT to ClearBlade. Could you elaborate on that for a second?
If you think about, we described this piece of software we built, we call it IoT Enterprise today. It's incredibly flexible, right? It's got the full broker in it. It has the device secure records. It has the ability to do cloud functioning inside of it in process. It has the ability to talk to downstream event flow services, pub sub services. So when the retirement happened, we basically said there's no function in that offering that our product doesn't already offer. As a matter of fact, really, it's just taking our product and narrowing it down to match the limitations or the requirements of that design. It had to do with, what topics could a device talk on, how does a device authenticate, what information is persisted in the system versus what information just moves down and is sent, and what APIs. So all we had to do was just go define a system that ran on us that matched that template, and we ultimately had recreated that solution. We have the ability to do the exact same thing with the other IoT providers out there, right? When you've built this kind of core middleware thing that's highly performant, it's easy to recreate the different patterns you see out there. That's what we did. Obviously, we learned a lot. We really then, if we look at what we had to do, we had to focus on migrating people. Then we focused on giving them a familiar user interface. And then we actually even matched the billing. So really a lot of it wasn't about can our product do what they're doing or how will they move this stuff. It was really just a matter of how can we make the business part of it simple, the administration part of it simple. And so we did invest in that portion. Went very well. We made it easy for lots of folks. Weren't the solution for everybody, but I would say a huge number are quite happy with this, and we continue to do our best and be our best partner we can with Google. We continue to provide lots of great value with their Google Cloud offering that we really love and are in the marketplace with.
So this once again highlights the approach that once you've got strong foundations, the framework that lets you operate, then you can basically create those APIs, those adapters that will fit nicely into other use cases, even use cases that were very hard to imagine. Because I'm pretty sure that you never thought that you will handle such mass of migration of customers to the ClearBlade, right?
Yeah, it's fascinatingly rare. You're right. It's hard to imagine. I mean, there's only probably 2 other people that have that many customers in one place, right, or more. No, it's interesting too, because if you think about what we did is now that offering could actually run on a remote gateway. So we literally created it and now could run what was a cloud hyperscaler like solution on any cloud, on any server, on any premise environment, or on the gateway. And that's a ton of flexibility as well for people, right? Before they were trying to say, well, I need support in India or in country, and now all of those use cases are unlocked for people.
Please highlight a few examples of how customers used your platform in very innovative way. And we will cover that in more details during a future episode, but just give us a few highlights that are maybe your favorite use cases.
Yeah, so we certainly have the traditional connected products. So we have a great partner that does their HVAC systems and monitors home hot water heaters and HVACs at very high scale. And that is a traditional one. They use pure the IoT enterprise offering for securely moving their data around. They have a great mobile app for how people interface with it. And so that one is definitely kind of a flagship way to look at a pure IoT product that's been very successful, and what a great team they are. We have another project. So our intelligent assets application is really trying to shorten the life cycle. And it's really designed for enterprises. And we have a railroad that literally is dropping this application, rolling it out with their existing hardware that they already had purchased, and monitoring infrastructure at the railroad. They're not having to build a custom app. They're not having to, put down new hardware. They're not having to put in new network. Essentially, it's able to work directly into their environment and stream data to actual operators. So the people that actually drive trucks to look at what's going on are opening this application on their phone and getting that data. I love that use case because that is truck rolls, that is money saved, and that's a great one. We've got, again, that application works great, works heavily in water and energy utility. Again, just monitoring what this equipment is in the field, not having to drive the truck to look at it. I love when we can get that up and running with people in a matter of weeks in the field. And I know weeks can sound like a long time to a software developer, but this requires screwing things in. This requires somebody going out in the field and plugging stuff up, and then when lightning strikes, having to replace it, right? So the real world is so much harder than just an AI data stream. It's so exciting when that works. The last one is we have a couple folks doing some inferencing at the edge. And, again, we knew distributed, centralized was a pattern, right? But being able to do like video processing at the edge and not send faces and private data to the cloud, that's a fantastic one. Being able to do that inferencing in that process on the piece of hardware they selected, that's been really cool. So, the inferencing also works well for, remote drilling and those sorts of things where you want to actually, make some predictions in the field. But I really do like seeing the edge AI begin to emerge as real use cases.
And by the way, edge AI is on our list as well. So everyone watching, please stay tuned.
I gave it all away.
yeah, you spoiled everything. But I think that's great. So let's cover what we discussed today, because there are quite a few topics. We started from the build and buy approaches, and you showed us how deep you need to go into technological stack in order to make the right decision regarding building stuff or maybe buying, and all of those constraints that you need to predict upfront, because otherwise you will be blocked a few months or even few years up the road. So that's a great checklist. And the use cases regarding how to organize the complexity, as you said, to narrow down number of abstractions that you're dealing with, and that the microservice approach is super cool and fancy and typically works, but you need to put some constraints around it, because otherwise it might get out of the hand. So those were great points from you, and the way that you support your customers, even in those extreme conditions like migrating from one provider to the ClearBlade and making it as smooth as possible, not only from technological perspective, but also from the business and operations. I think that's a huge point. So that's a lot of information, but if you could deliver a single message to our viewers, what would that be?
My big message is trying to build this stuff from scratch is hard. I've got 12 years at it under my belt, and we continue to make it better and better. And to start from scratch is a tough spot to be in. I highly encourage folks to look at, what is this real challenge? Where are we really going to go? What happens if we're successful? And I would highly recommend taking a strong look at our product or others who've solved this problem for you and potentially can meet those requirements. Overwhelmingly, we see that as a way to avoid lots of frustration and downtime and pain, but also to save money in the end, just trying to support and maintain this. So that's my takeaway. Again, this is obviously an area that will continue to improve, and I'm sure we'll see new projects come out there that can deliver more. But at this point in our IoT market, I lean heavily into find a partner who has done this, is doing this, and continues to healthily invest in it, and they can take you down go down your IoT journey with you.
Thank you so much for this conversation. I learned a lot from your experience. I'm sure the viewers as well. So thank you for sharing all of those technical and operational aspects with us.
I enjoyed it, Lukasz. Thank you.
Next time, we're going to talk about the digital twins and intelligent assets, essentially built on top of what we discussed today. If you've got any questions to Aaron, please put them in comments, and we will answer them live during the live stream that concludes this video series. Till next time, I'm your host, Lukasz Malinowski.